I'm Alisa. I work as a data scientist at E.ON Digital Technology in our data and AI department. So we're basically an internal consultancy and we provide our data and AI services or projects basically to all of E.ON Group. We are over 150 data scientists and data engineers already in the unit, and yeah, as I said, we serve the whole of E.ON for different kind of use cases related to data and AI. So for example, how we can make our grids more efficient, more stable, or how we can improve our customer service, make it more efficient. So that's kind of more on the energy retail side. And the energy retail side is actually where I'm coming from. So today I also have the pleasure to tell you a bit about LLMs and how to evaluate them in real world scenarios. So basically LLMs in the wild, specific to classification at the beginning. So LLMs for classification, how hard can it actually be? And yeah, this is me 1 year ago asking the exact same question. I mean, compared to normal machine learning workflows, let's say from 5 years ago, where we needed to get a bunch of data, label it, think about the best model, the best architecture, hyperparameter tuning, train, test, split, everything. Classification using LLMs is surprisingly simple, right? Like what we do is we define our inputs, what we want to classify, we write our prompt, we run everything to our model, and we get the label. So yeah, it kind of even sounds too good to be true, right? It sounds a bit too, this simplicity is deceptive. So if we take a look at a realistic scenario, let's say classifying support tickets for IT, what we might encounter is, let's say, emails from our internal employees that maybe in this case complain that they cannot connect to the VPN since this morning, that they're getting some invalid credentials, but their password works, of course, as always. So what are we going to do now? It's super easy. We just write our prompt. We say, please, GPT, Mistral, Gemini, please classify this beautiful email into these categories. It could be VPN issue, network issue, credentials, access, whatever. We just pass it through the LLM and get our prediction, which is a VPN issue. But yeah, what are we doing here actually? We're not trying to classify cats and dogs, right? Like we're actually asking the LLM to differentiate between potentially 50, 100, 150 different classes, which are maybe not so different after all. Maybe they're very ambiguous, maybe they're too similar basically. And I always like to use this analogy of saying we're not classifying cats and dogs, we're classifying between 150 siblings. So this makes things a bit more challenging. And in the case of IT support tickets, picking the wrong class is not harmless, because if we don't predict the correct class, the wrong team will get the email from our employee and everything will get delayed and it will cost more ultimately. Another thing that makes things a bit more challenging is that, once we develop LLMs and deploy them, everyone starts asking questions. So we might have the business or the stakeholder asking, okay, we moved now from whatever we had before to GPT. Are we better now? On the other hand, we will have the people from the support side, so basically our target user group that actually take care of these emails on a day-to-day basis, and then they will say, okay, cool, you have a new model, but if this model is not accurate, I will have an issue because the tickets will keep bouncing back and I will have more work, I'll be more frustrated. So LLM predictions are becoming cheaper and cheaper, right? Like the cost per token is sinking. So yeah, LLMs become cheap, but evidence on whether or not they perform well is not cheap. And we actually need to have a systematic way in order to measure whether this system that we're developing is performing well in the wild or in production. one thing before we actually start, so basically, again, I think you already realized that the crux of my talk today is not going to be some fancy new agent approach or some latest LLM development. It's going to be on evaluation, because from my personal experience, you only need 20% of the time to develop something with LLMs, but 80% to evaluate. And we're going to talk about a practical framework on how to do this. But before we dive into the framework, I wanted to just, let's say, remind ourselves on what are some of the challenges that we might expect in a classification problem like this, whether or not it's machine learning or LLM, so just like the general framing. What can we expect from our data? What problems can we expect? So we have our email. It's coming from an internal employee that can have many different things happening to them on a daily basis. And then we should define our taxonomy, right? Like we should define all of the possible classes that the system should be able to predict. And this can be a lot of different things. This can be issues related to hardware, to software, to network, to credentials, to everything. And we can see that these are usually, kind of also hierarchical, right? Like, so we might have different groupings of labels. And the first thing that is very apparent, maybe not displayed on the screen fully because I would run out of space, but we're faced with a high cardinality problem. We have normally in this kind of real world scenarios, we have way more than 50 classes, maybe sometimes 150 or 200. And this is inherently challenging. Then the hierarchy is also making things potentially more complicated because maybe we have different teams behind the different levels. So there's not maybe the hardware and software team of experts who are dealing with these issues is not the same. So this hierarchy is important. We cannot just push everything into the same level. Another thing that is also making things a bit more complicated is the potentially overlapping semantics. So let's say we get an email related to the email clients that a user is having a problem with their Outlook, but we also have the application class. So isn't an email client also kind of an application? So what is the exact process behind what's happening? Then another very challenging thing is the fact that these emails can also be multi-label. So the user or the employee that is actually raising a support ticket can have two or multiple problems at once. Maybe they say, okay, my laptop is crashing when I update this application. So those are equally valid concerns that the support team should take a look at. And then finally, these kind of problems are usually plagued by long tail class imbalance. So we inherently expect that some problems are going to be more common than others. So maybe password resets happens every day, at least to me, at least twice a year. But yeah, firewall issues or maybe certificate expiration, some severe issues, we don't expect that. But LLMs, of course, make things even more complicated. And they introduce unique challenges, which can be clustered in 3 different dimensions. The first one is ambiguity. And you can argue, okay, well, yeah, but this problem is inherently maybe ambiguous because how do you actually define the categories? Well, the thing is that LLMs make things, the barrier to entry to classification systems very low because LLMs are very good at understanding nuance in texts, but only if these classes are well defined. And actually the human annotators or the humans who are actually defining the classes may not even agree with each other. So one thing that we could do is measure metrics like, for example, human-to-human coins kappa, which basically measures the agreement between several annotators in, let's say, when they label tickets. And this is basically acting as a kind of an upper ceiling of the ambiguity in our data set. So if we actually label some data with 2 or 3 annotators and we get a very low agreement, we can already sense that this is going to be a very challenging problem also for the LLM to classify. Then inconsistency. So I don't know if I should talk much. I can just ask you to raise your hand if you've ever sent the same input twice to an LLM and gotten different answers. Anyone? Yeah, exactly. So, I mean, LLMs are by nature non-deterministic, right? So if we don't have the guarantee that the same input will always result with the same output, and also comes the prompt sensitivity. So if we change small things in the prompt, we can expect some also variation in the predicted classes. Of course, what we want to optimize here is the probability that the LLM will always predict the same for the same class for the same input. And then last but not least, a very interesting and important challenge in LLMs is, and in general for these kind of systems, is drift. Because the system is not stable, it changes over time. So for example, we get new ticket types, that's data drift. We get, maybe we agree that now network issue is defined a bit differently from VPN issue, which means that our class definitions change. That is model drift, concept drift. And of course, this is specific to LLMs maybe, or more pronounced, so to say, model drift, because we're mostly using black box models that we don't know what's actually happening under the hood. So whenever OpenAI decides to update the model, we can probably expect different results. And again, we can measure things here. We can measure stuff like Jensen-Shannon divergence, which basically is a measure between the difference or shift between two distributions. And if we say, for example, we run the this divergence calculation on two different model types, if we see, let's say, specific value, this basically both of these values actually that you see on the screen have to be empirically decided. If we see a shift, then at least we know that something's changing. We know that something's happening in the system. And before I finally come to what we're all here for, the evaluation framework, I just wanted to raise again the importance of knowing what you're evaluating for. So I think, I've been guilty in the past of only looking at some data science-y performance metrics and not maybe asking behind the real world impact behind it. So let's say we take the usual example of having a very high accuracy, but a very different class distribution within this number. So let's say if we have a super common class, which constitutes 80% of our data in production, and which is super easy to solve, network problems. I don't know if that's true, it's just an example. But we have a very uncommon class, which is very, very costly, and it amounts maybe to 1%. Still, this metric can be misleading, because if we fail to predict well on the firewall class, for example, we have a negative impact on our business metrics. What can this be? This can be, for example, an increase in our mean time to resolution. So our tickets take longer to resolve, and our users are unhappy, our agents are unhappy, everyone's unhappy. We get a bigger bounce rate between the agents, and of course the costs just increase. So again, just this thing that's probably not new for anyone, but just to kind of put the importance, or to put the emphasis that we should always keep in mind which error classes, which classes are more severe than others, and kind of to have this in mind when we're evaluating our systems. So finally, I would like to introduce you today to a framework, or rather a toolbox of things that you can do in order to get a feeling of how good your LLM system performs. And this framework or toolbox will be able to help you understand how your system performs throughout the whole project lifecycle. So from development to maybe staging or testing, and all the way into production. This framework is centered around 3 components. They're not maybe hierarchical, so not like LLMs judge is the most important. It's just the representation here. We want to say that basically all of these 3 components work together in order to give you a better feeling of how good your system is performing. So we'll start first with the golden data sets, which is your technical ground truth, and which is something that you can use during your development phase. We'll talk about each and every one of these components in a greater detail later. But just to quickly introduce, we have then the semantic and robustness evaluation with LLMs as a judge. And of course, the human feedback. So how do we track the system performance once it's deployed? So as I said, let's take a look at each one of these components in a bit of detail, what they are, how they work, and what metrics they enable you to record and then analyze. As a refresher, golden data sets, there are basically a collection of labeled cases. In this case, this would be a collection of labeled tickets that maybe, they have been taken. Some human annotators have sat down and assigned the correct label. Ideally, we have multiple annotators taking care of this curation of the golden data set, because then we have a bit of less bias in one direction or the other. And what these golden data sets enable us to do is they enable us to run different model benchmarks. So we can take different model types, we can configure the LLMs in different ways, we can take zero-shot, few-shot approach, and we can run the predictions on the golden data set, and we can juxtapose them, the true labels with the predicted labels, and see how correct or wrong they were. And the first thing that we can do is maybe, sounds pretty straightforward, and we have done this in the past with normal machine learning models, confusion matrices. Confusion matrices are actually a very, very powerful tool that can help you identify. So if you take a look at everything that's outside of the diagonal, you'll be able to understand, okay, what classes am I predicting poorly? What classes am I confusing with each other? Maybe what classes are very important but rare in my data set, and what's happening there? So this is like a straightforward but very powerful tool that you can use to actually gauge the performance of a specific model. What metrics can we measure with golden datasets? Of course, the normal standard ones, as with any classification problem, we can compute per class or overall precision recall. We can compute macro, micro, weighted F1 score, and then kind of have a feeling of how well we're performing on this set of agreed samples. What golden datasets also allow us to do is measure the system stability. So, for example, if we run different types of models, let's say GPT-4 and GPT-5, on the same golden dataset, we'll be able to assess whether, let's say, the distribution of the prediction has changed a lot, and why, which one is more favorable maybe to us. Golden datasets, especially if you version them, they can also help you understand, okay, if I maybe if I want to take a new model into production, because maybe I'm experimenting and I want to know, okay, I need to achieve at least the same level of performance as before in order to take some other model to production. So this could be the first step. And of course, other different things. So we could, let's say if we're asking our LLM also to predict or output a confidence together with the label, we can also monitor, okay, has the confidence decreased over time on the golden dataset and for different model versions. And finally, which is something which is also very, very powerful, is that when you have your technical metrics, you can try to map them, well, not try, but you should aim to map them also to a business impact. So when you know, for example, how severe some classes are, maybe how much they cost to actually address in production by the agents, you could try to estimate the costs that your system is bringing. You can estimate the cost or the reduction in mean average handling time or projected handover reduction. So this is basically also a very important tool that you can also bring to your stakeholders and say, hey, what we're doing here really is bringing impact, it's really performing well, and we can actually save money with this. So golden datasets provide reproducibility and regression checks. So it's actually a very good tool. Then coming to the second component of our evaluation systems, LLMs as a judge. These are basically tools that you can use to kind of understand the performance from a bit of a more semantic point of view. And just as a refresher, how does LLM as a judge work? So we have our data that is coming, in this case our ticket, our support ticket. We have run the LLM inference already, so let's say with Gemini, right? And we have gotten the class, which is the VPN issue. And then we use a different model, ideally from a different family, let's say GPT-5, to actually judge the quality of the prediction of the first model on the given text. And we can let the LLM as a judge output a specific score from, let's say, 0 to 1, whether or not the prediction was correct, plus a reasoning. And how does this work? Again, grounded in our example from before, we have our email coming in with the VPN issue, but maybe with something else too. Then we had our LLM inference with the prompt asking to classify the different classes. We predicted the VPN issue as a class. And then we asked another LLM to evaluate if the predicted label is correct for the given text. And so, and so the other model is actually saying 0.8 because, in theory, you have mentioned the VPN failure, but there's also probably something else going on, the rejected credentials. So this is how it works. What can you do with it, or how could you use it in real life? And you can use LLM as a judge both on the golden dataset that we spoke about before, but maybe a bit more interesting is production data. So when you already are running in production, or maybe staging, I don't know, when you're still evaluating, that you basically take your predictions that you have made with your first LLM. And then what you could do here is either randomly sample from prediction, because at the end of the day, what you're doing is making another LLM call. You may not want to do it for every sample because then the cost is double. Or you may want to selectively sample. Maybe you're interested in, okay, how good am I performing on my very critical classes, right? Like these firewall issues. Because if we have a very long tail distribution and we pick random samples, the probability that we sample from these critical classes is of course lower. So we sample, we put it through the LLM judge, and we can compute metrics. Again, what kind of metrics? We can compute the judge to model agreement rate, which is basically how often does the judge agree with the original LLM prediction. And this is basically an indicator that you can have. So if you used to have maybe 94% agreement, and then after a while it starts dropping, it does not tell you what exactly is happening, but it tells you that something is happening in the system and that you should take a closer look, because it could potentially negatively impact your business metrics at the end. Then you could also take a look at the classes that are getting rejected by the LLM as a judge, maybe more often. Maybe you will see that you have a lot of network issues that are actually then being rejected by the LLM as a judge as maybe hardware issues. And then this will help you prioritize to see, what is actually happening in this class. And then finally, what the LLM as a judge can give you is an indication of an emerging class. So maybe you will see that after a while, the LLM as a judge keeps saying, I don't know what this is. This is definitely not a VPN issue, but I don't know what this is. So this means that you might have a different ticket type emerging from your data that you maybe have not foreseen before, and that you should take a look at your taxonomy and maybe update your prompt. So what the LLM judge does is it helps you quantify how wrong your model is and not just whether or not it's wrong. Good. Then last pillar is the human feedback, and human feedback is actually the kind of the real world system performance. So when we have already rolled out our system to our users, how how are our users interacting with the system? In this case, users means, in this case would be the IT support crew. How would we actually track human feedback? So let's say that we have developed our LLM classification model, and it's, let's say, classifying tickets and already inputting the predicted labels into our CRM, which the customer, well, the IT support crew is working on. So we say maybe we predict a VPN issue, but then a human agent goes and corrects this. Because they say they maybe take a look and actually say, yeah, it's not a VPN, it's a credentials issue. So what we need to do as developers there is try to lock what happened, lock this change of label. So to say, okay, what ticket was it? What was the original label and what was the corrected label? And then this will enable us, again, to run analysis and metrics, to compute metrics. We'll see the metrics on the next slide. But the analysis will basically allow us to say, okay, we can try to cluster the different issues that have been corrected, to say, okay, maybe I'm actually missing, my LLM is missing a lot of multi-factor authentication related issues. So this would mean that maybe I need to take a look at my taxonomy and maybe add a different class for multi-factor authentication or refine my prompt. And of course, the kind of side effect of tracking human feedback is that you actually get a golden data set, which is already aligned and labeled by humans. And you could basically take some samples labeled by humans and then plug them back into your golden data set. What metrics can we, because we talk about metrics, what metrics can we track with human performance signals or system performance signals or human feedback? If we track the number of corrected labels, so the number of times that the agent clicks no, this is the wrong prediction, we can have the misclassification rate, which will then, the lower it is, the better our mean time to resolution is and the lower our cost. And if we see a rise in the misclassification rate, that will signal maybe that we need to take a look at our prompt as we spoke, or we need to try a different approach, maybe a few-shot classification with some examples from the humans that were, let's say, labeled again. The number of rerouted tickets, so basically how often do the tickets bounce back between agents, will, of course, negatively impact our service level agreement, and we don't want that. So if we see a steep increase in the handover rate, we should think about maybe some escalation mechanisms or maybe some better routing rules that we can basically make sure that the tickets are getting resolved quicker. And finally, this analysis that I spoke about, if we actually take a look at, okay, what kind of issues are getting corrected by the agents, we can see, okay, is this a very critical issue? And we can then, because maybe again, I take the example of the firewall, maybe then I should come up with a targeted way to improve the performance of this class by maybe creating a better prompt or a better phrasing of the prompt or of the description, or maybe just create split the class into two and So we spoke about this whole framework, right? Like the toolbox, the three different pillars, and maybe as a school assignment or as a homework, we've learned the method, and let's try to apply it 3 times. Because this system is actually not specific to classification. We took classification example, but it can be very easily adapted to other types of LLM problems, like for example extraction, and maybe even retrieval augmented generation. So I brought the example of extracting fields from invoices using LLMs. The golden data set here will be a hand-labeled collection of documents where we set maybe some people to kind of map, okay, this is the document and this is these are the extracted fields that we expect. Then we'll have the LLM as a judge the extraction in production between 0 and 1, whether or not it was a correct or incorrect extraction. And then finally, we would of course need to track the finance team. What are they doing? Like, how are they interacting with the system? Are they correcting our labels very often, and then maybe taking some steps to improve the performance? For RAG, how might this look like? We could have, for a golden dataset, we could assess the retrieval part by having a set of documents and the retrieved set of questions and the retrieved documents that we would expect for this question. And then LLM as a judge would actually judge the answer by the LLM and ask it, okay, has the answer been, well, basically do a fact check on the first LLM. Is it complete? Is it hallucinated? Basically, what's the quality of the answer? And of course, at the end of the day, the indication of how well our system is performing for RAG is the number of times that the user either rejects our question, maybe puts a thumbs down, or tries to ask the same question twice, because maybe that's happened to you as well, that you were maybe not very fully happy with the answer you get and you just try to rephrase the question. So this is actually signal that we should track. Finally, coming back to our slide with the framework for continuous evaluation. So the goal here is that these three components will help us answer different questions that all come together. So we say with the golden datasets, we can know how good is our model on known truth, so truth that has been already defined by people. The LLM as a judge can give us an indication of, are we still performing well? So kind of like you can think, I like to think about it as a guardrail, like, okay, am I still moving in the right direction? And then the human feedback is actually the real world performance. So how good does our model behave in reality? And yeah, if you combine all of these tools, or maybe parts of the metrics, maybe in a nice dashboard with different levels, maybe targeted at different user groups, maybe developers all the way to business people, you have already a way to measure things. You can stress test things, and you can evaluate different assumptions. Then you can learn from what's happening in production, and then you can update your approach. And before I wrap up, I would like to leave you with an analogy of this framework. So you can think about this framework as maybe, okay, so let's say your LLM classification problem, or let's say LLM problem, is you driving your car from A to B. And so the golden dataset you can think of as your navigation system, which is telling you, okay, where do you want to, which trajectory do you want to take, how fast are you moving, and basically making sure that you're keeping on track. And the LLM as a judge has a complementary role of the road that doesn't let you kind of like steer off the woods and just go somewhere. And the human feedback is the child sitting in your back seat, which is asking you, are we there yet? Which is sometimes maybe brutally honest, but still equally valuable in order to know where your journey is taking you. And with that, that's all I have for you today.
Thank you for the talk. That was nice.